The array type. Another way to have a collection of multiple values with an array. Unlike a tuple, every element of an array must have the same type. Okay, so it's a different thing. Okay, so unlike arrays in some other languages, arrays in Rust have a fixed length. We write the values in an array as a comma-separated list inside the square brackets. Arrays are useful when you want your data located on the stack rather than the heap. We will discuss the stack and the heap more in chapter 4. Or when you want to ensure you always have a fixed number of elements. Arrays are useful when you want your data allocated on the stack rather than the heap. Arrays are useful when you want your data located on the stack rather than the heap. We will discuss the stack and the heap more in chapter 4. Or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as the vector type. A vector is a similar collection type provided by the standard library that is allowed to grow or shrink in size. If you are unsure whether to use an array or a vector, chances are you should use a vector. Chapter 8 discusses vectors in more detail. However, arrays are more useful when you know the number of elements will not need to change. However, arrays are more useful when you know the number of elements will not need to change. For example, if you were using the names of the months in a program, you would probably use an array rather than a vector because you know it will always contain 12 elements. You write an array type using square brackets with the type of each element. You write an arrays type using brackets. Brackets with the type of each element, a semicolon, and then the number of elements in the array, like so. Here, iterate2 is the type of each element. After the semicolon, the number 5 indicates the array contains the 5 elements. You can also initialize an array to contain the same value for each element by specifying the initial value followed by a semicolon, and then the length of the array in square brackets as shown here. You can also initialize an array. You can also initialize an array to contain the same value for each element by specifying the initial value. You can also initialize an array to contain the same value for each element by specifying the initial value. Here, iterate2 is the type of each element after the semicolon. Okay. Number 5 indicates the array contains 5 elements. You can also initialize an array to contain the same value for each element by specifying the initial value. You can also initialize an array to contain the same value. Okay. And then the length of the array in square brackets, as shown here. The array named A will contain 5 elements that will be set to the value 3 initially. That is the same as writing, but in a more concise way. Accessing array elements. An array is a single chunk of memory of a known. An array is a single chunk of memory of a known fixed size that can be allocated on the stack. You can access the elements of an array using indexing, like this. You can access elements of an array using indexing like this. In this example, the variable named in this example, in this example, the variable name first will get the value 1. The variable name first will get the value 1. Because that is the value at index 0 in the array. The variable name second will get the value 2. The variable name second will get the value 2. Okay. So from index 1 in the array, from index what? Okay, yes. Invalid array element access. Let's see what happens if you try to access an element of an array that is past the end of the array. So what happens if you try to access an element of an array that is past the end of the array? Say you run this code similar of the guessing game in chapter 2 to get an array index from the user. String new, okay, getting index, and index use size because, okay, makes sense. Because the indexing, like you just say use size or I size, yes. But use size because it cannot be minus. Stream parse element a index. This code compiles successfully if you run this code using cargo run and enter. The program will print out the corresponding values at that index in the array. If you instead enter a number past the end of the array, such as 10, you will see output like this. Thread man panicked at index out of bounds. The len is 5, but the index is 10. The program resulted in a runtime error at the point of using an invalid value in the indexing operation. Runtime error. Okay. The program exceeded with an error message and didn't execute the final println statement. When you attempt to access an element using indexing, Rust will check that the index you've specified is less than the array length. If the index is greater than or equal to the length, Rust will panic. This check was to happen at runtime, especially in this case. This check has to happen at runtime, especially in this case, because the compiler can't possibly know what value a user will enter when they run the code later. This makes sense, yeah. This is an example of Rust's memory safety principles in action. In many low-level languages, this kind of check is not done. And when you provide an incorrect index, this kind of check is not done. And when you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. Chapter 9 discusses more of Rust's error handling and how you can write readable safe code that neither panics nor allows invalid memory access. So there's the quiz. So question 1. Determine whether the program will pass the compiler. If it passes, say what will happen when it is executed. If it does not pass, say what kind of compiler error you still get. The temperature today is Oh, the temperature today is also year. It's a string, so the array should have the same type. Each element should have the same type. Does not compile. And question 2. Determine whether the program will pass the compiler. If it passes, say what will happen when it is executed. If it does not pass, say what kind of compiler error you will get. So it's a tuple with the array, so 1 and 1 1 and 3 3 3 3 3. So T and then destructuring tuple A 1 1. So 1 1. T point to 1. Does it compile? It's A0. Definitely 1 plus 3, so 4. But incorrect error, kill the number. The error occurs on the line number none. What? The error occurs on the line number none. This program does not compile. Yes, does not compile. The error occurs on the line number. The error occurs on the line. Oh shit. The error occurs on the line. Fuck. Yep. Here. 3. Doesn't compile. 4. Boom. Yes. Great. Functions.